Hello students. So today we are here again to do some revision work from chapter number 2. The last video online class we have discussed about the valency, anatomicity, that one have some problem in valency also. We have discussed about that. And we are just talking about how to derive a chemical formula. Some of the students have said they know how to derive a chemical formula, but some of the students are still there who don't know how to derive the chemical formula. So today in this video class, I will explain you again how to frame a chemical formula. As I have already told you that to frame a chemical formula, we should always remember the symbol of the elements and their valency. If you remember the valency and the symbol of an element, then you can easily make or frame the equation of a chemical compound. So, first of all, we will do some basic types of chemical formula. Suppose if I take an example of carbon dioxide. Suppose if you take a carbon dioxide, what is the chemical formula of carbon dioxide? So as from the name you know, here is carbon is there and oxygen is there, and the valency of carbon is 4, just write 4, and valency of oxygen 2 here. After that, when you do the crisscross, what will get? C2O4. Okay. Now this 2 and 4 has a common factor 2, so you can do the cancellations. So 2 1s are 2, 2 2s are 4. Ultimately we get CO2 as a formula of carbon dioxide. In this way you can do this to make a chemical formula. Now one more simple equation formula I want to explain you, that is sodium chloride. Sodium chloride. As from the name you can understand, sodium is there and chlorine is there. The symbol of sodium is Na and that of chlorine is Cl. Now sodium is having a valency 1. Okay. So you can write here 4 like this. It's better to write the top. So 1 plus it is minus 1. So when you do the crisscross, what will get? Simply NaCl. So formula of sodium chloride is NaCl. In the similar manner, if you want to make a chemical formula, magnesium oxide. Magnesium oxide. What is the formula of magnesium oxide? So again, symbol of magnesium is Mg and oxygen is 2. Now you have to write the valency of magnesium oxygen. Valency of magnesium is 2 plus and is 2 minus. So when you do the crisscross, you will get Mg2O2. So by common factor 2 1s are 2, 2 1s are 2. So you will get MgO as magnesium oxide. In this way you can frame the formula of magnesium oxide. Okay. Now if you want to make some more formula, if you want to practice, you have some questions like here also. Like next one is magnesium, so copper sulfide. We will draw the formula of copper sulfide. Okay. Or calcium sulfide also you can do. So calcium sulfide. Calcium sulfide. So calcium is Ca, you know, calcium is Ca and sulfide is S. Both calcium and sulfide are having valency 2. Okay, so it will be 2 plus and it is 2 minus. When you do the crisscross, you will get Ca2S2. So 2 2 you will get CaS. You will get the formula of calcium sulfide 2As. In this way you can make the formula. So students, now I think you have understood how to frame a chemical formula. Okay. So the next part of this chapter that we want to do the revision work, that is from the mixture. As I've told you in the last video class that today I will give you some description in the mixture also. As you know, the mixture are the impure substances. They are made up of any two or more elements or compounds or solutes and solvent in indefinite proportion. Means they have no definite compositions. Suppose the mixture does not have a definite composition, made up more of two types of pure substance in varying quantities. Suppose if you take a glass of water, if you put 1 tablespoon of sugar, that is also a sugar solution. If you put 2 tablespoons of sugar, then also it's a sugar solution, but it is a mixture because composition is not fixed. They have no fixed properties. As they don't have any fixed composition, they also don't have any fixed properties. And the constraint of a mixture can be separated by simple physical method. Simple physical method, that is by evaporation, condensation, then distillation, then you can follow decantation, sedimentation process also sometime. Okay, filtration, etc. And the constraint of the mixture retain their properties as it does not form any new substances. So no chemical reactions takes place while in formation of mixture. The chemical properties still remains the same. Okay, of the constraint elements. So the mixture have the difference between mixture and compounds. Mixture can form with 2 or more substances in physically they mix together, but in compound they mix together chemically. Mixture does not have fixed composition, but compounds have their fixed composition. Mixture cannot be represented by a chemical formula, but compounds can be represented by a chemical formula. Always we have to represent by a chemical formula. The constraint of substance retain their chemical properties in a mixture, but in a compound the constraint does not retain their chemical properties. The constituent substances can be separated from each other easily by physical means such as sieving, sedimentation, decantation, filtration, evaporation, etc. But constraint of a compound cannot be separated by any physical method. They can be separated by some special method like electrolysis. Okay. For example, electrolysis we can follow. You will study it in your higher class. Now, next is the difference between air mixture and compound. Why air is a mixture, not a compound? Air is a combination of gases like nitrogen, carbon dioxide, oxygen, other noble gases, water vapor and dust. But this composition is not fixed. They vary from one place to another place. Okay. So since the composition is not fixed, it is a mixture of air. It cannot be represented by a chemical formula. Okay, and the constraint of air like nitrogen, oxygen can be separated out of their by physical method that we will study in your higher classes. So in this way you can differentiate between mixture and compounds, and why air is called a mixture. You have got the answer. Okay. Now the next is the types of mixture. Mixture are of two types. One is heterogeneous mixture, another is homogeneous mixture. What are heterogeneous mixture? Heterogeneous mixture are those mixture in which the constraint of mixture does not mix uniformly. They does not mix uniformly, they are called, means non-uniformly distributed, are called heterogeneous mixture. For example, sand and water, sand and sugar, oil in water, soil and iron, different fruits and vegetables in salad, etc. So they are heterogeneous mixture. Homogeneous mixture, just opposite, the constituent of the mixture they combine uniformly. Okay, they uniformly distributed and known as homogeneous. For example, there are so many homogeneous mixture: milk, honey, lemonade, squash, fizzy drinks, normal solution of salt and water, then sugar and water. All are the examples of homogeneous mixture. Stainless steel, homogeneous mixture of iron, cobalt and nickel, etc. Then this mixture can be divided into one more, that is called, if you take a homogeneous mixture or heterogeneous mixture of salt with a water, or so water with any of the salt substance that get dissolved in water slowly or fast, they are called solution. So water solution is a special type of homogeneous mixture in which small quantity of component is mixed uniformly with a large quantity of another component, is called a solution. So the component which is get dissolved in a small quantity is called solute, but the quantity which is much more, in which solute get dissolved, they are called solvent. So solute plus solvent is called a solution. Okay students, so these are the video revision that we have done today. In the next video class we will do some discussion about the separation techniques of constituent of mixture, and our chapter will be, revision of chapter 2 will be completed in the next video class. After that we will do the revision of other chapters also. I have done this chapter first because this chapter was in your half yearly exam, which was about 5 months ago. That's why I have given the revision. I hope you have understood and go through the chapter once more. Thank you very much for watching this video. See you again in the next video class. Thank you very much.